Hi there. Today we will be looking at ways of solving linear inequalities, now that we know from the previous lesson what a linear inequality is. By the end of this lesson, you should be able to solve a simple linear inequality, solve a linear inequality that involves multiplying or dividing by a negative number, and calculate values for a linear inequality. When you worked with linear equations, your teacher probably drummed into your head one important concept. Whatever you do to the one side of the equation, you must do to the other side of the equation. For example, x equals 8. If you add 3 to the one side, x plus 3, then you must add 3 to the other side, 8 plus 3. Otherwise, your equation cannot be true anymore. If you subtract, multiply, or divide one side, you must subtract, multiply, or divide the other side. So, if x equals 8, we can say x minus 6 is equal to 8 minus 6. Similarly, if x is equal to 8, we can say 3 times x is the same as 3 times 8. Lastly, we could say x divided by 4 is the same as 8 divided by 4. Now we need to investigate whether the same operation rules apply to an inequality. The best way to test rules is to use simple examples, ones that we already know what the answer should be. So, is this statement true? Yes, of course 1 is less than 4. Easy. Okay, we are going to take 1 less than 4 and do some maths on it. We want to see how operations on numbers affect the inequality. What happens if we add 3 to both sides of our inequality? So we write 1 plus 3 is less than 4 plus 3. So we get 4 is less than 7. So, is this inequality still true? Yes, 4 is still less than 7. Now, what happens if we subtract 2 from both sides? So, we're going to say 4 subtracted 2 smaller than 7 subtract 2. And we end up with 2 less than 5. Yes, this inequality is still true. Now, what happens when we multiply both sides by 4? So we have 2 less than 5, and now we're going to say 2 times by 4 is less than 5 times by 4. So we get 8 is less than 20. And yes, that is still true. So far, we have added, subtracted, or multiplied by a positive number on both sides of the inequality, and they have remained true. What happens when we divide both sides of the inequality by 2? Let's see. So we have 8 divided by 2 is less than 20 divided by 2. And we get on this side 4 is less than 10. And yes, this inequality is still true. So to recap, what we have discovered so far: if we add, subtract, multiply, or divide a linear inequality by a positive number on both sides, the inequality remains true. Let's look at an example. Bussi's class is collecting cans for recycling. Their goal is to fill 10 black bags with cans per week. They work out that to do this, they each need to collect more than 60 cans in a week. Bussi plans to collect cans 4 times a week. How many cans must she collect each time to reach her goal for the week? Before we set up an inequality to answer this, think about the problem and see if you can find the answer using common sense. Did you get 15? Me too. Now let's see if we get the same answer using a linear inequality. It's always useful to use a variable like x for the unknown. So let's call the number of cans she needs to collect each time x. So 4 times a week will be 4 times the number of cans, which needs to be greater than 60. So let's write that as 4 times x is greater than 60. And now we need to divide both sides by 4, which leaves us with x is greater than 15. So she must collect more than 15 cans each time. Well, see if you can solve the next example. Solve for x if 3x minus 5 is greater than or equal to 7. So the first thing we need to do is get rid of this minus 5. So we say 3x minus 5. Now we add 5 onto both sides. So we get 7 plus 5. Now we simplify and we get 3x is greater than or equal to 12. We now need to get rid of our 3. So we divide by 3 on this side, which means we've got to divide by 3 on that side. And we get x is greater than or equal to 4. Try this one then. Solve for x. Now, the first thing we need to do is get rid of our brackets by using the distributive law. So, 1 plus 6x plus 3 is less than 2x plus 4 minus 2. Now we need to add our like terms on either side. So we get 4 plus 6x is less than 2x plus 2. Now let's get all the x's onto the left-hand side. So 6x minus 2x is less than 2 minus 4. Adding our like terms again, we get 4x is less than minus 2. And lastly, we divide through by 4 onto both sides, and we end up with x is smaller than minus a half. The question you should be asking yourself already is, does the same hold for negative numbers? Can we add and subtract a negative number on both sides without this affecting the truth of the linear inequality? Well, we did that already. 4 is less than 7, then 4 minus 2 is still less than 7 minus 2 because 2 is less than 5. That is definitely true. But can we multiply or divide a negative number without affecting the inequality sign? Here's an example. Now you know that 2 is less than 5. What happens if we multiply by a negative number? Can we say that 2 multiplied by minus 3 is less than 5 multiplied by minus 3? This side gives us minus 6 is less than minus 15. Let's check this on a number line. Minus 6 is closer to 0 on the number line than minus 15 is to 0. So your answer is no. Minus 6 is definitely bigger than minus 15. How can we make the inequality true? We will need to change the direction of the inequality sign. Is it true to say that minus 6 is greater than minus 15? Yes, this is true. So remember this so you don't get caught out. If you multiply by a negative number on both sides of an inequality, you have to change the direction of the inequality sign. Otherwise, your inequality is no longer true. Would the statement still be true if we divide by a negative number? Let's have a look. Now you know that 2 is greater than minus 4. Let's divide both sides of the inequality by minus 4. So we're going to get 2 divided by minus 4. And we're going to get minus 4 divided by minus 4. Now, is that still true? Let's check. Minus a half is greater than positive 1. Let's take a look on the number line. No, 1 is definitely bigger than minus a half. So how do we make the inequality true? Again, we need to change the inequality sign. So, just like when you multiply with a negative number, if you divide by a negative number on both sides of an inequality, you have to change the direction of the inequality sign. Otherwise, your inequality is no longer true. Ready for another example? Now we need to solve for x. So the first thing we need to do is multiply our brackets out. So we get 2x minus 4 using the distributive law plus 2 is less than 1 plus, multiplying out again, 6x plus 3. Now let's just add our like terms on either side. So we get 2x minus 2 is less than 4 plus 6x. Now let's get all the x's onto the left-hand side. So we get 2x minus 6x is less than 4 plus 2. Adding our like terms once again, we get minus 4x is less than 6. Now we need to divide by a minus. Now don't forget we've got to swap the inequality sign around. So we divide through that side by minus 4, that side by minus 4, but now we actually do it. So we get x, swap the sign around, is greater than minus 6 over 4. And we should write that in simplified form as x is greater than minus 3 over 2. In an inequality, the sign stays the same when we add or subtract any number on both sides. But when we multiply or divide by a negative number, we have to change the direction of the sign. And here's a couple for you to try yourselves. Solve these linear inequalities. Minus 3 multiplied by z plus 2 is less than or equal to 2 multiplied by z minus 1. The second one is p plus 5 all divided by 3 is greater than 1 minus p. Hamba gashle, until we see you next time.